All right, good morning. We're going to finish up with Intro to College Math. Our last section we have to cover is 10.4. It's adding, subtracting, multiplying radical expressions. Before we get into the meat of that, I just again want to kind of review where we're at right now. So again, this is that last section. On Monday, we talked about 10.1 and 10.3. 10.4 just got a few new concepts, but a lot of it is what you learned in 10.3. But so again, 3 sections in this for this final exam, or for the chapter 10 exam. We're covering this last section, 10.4. So you'll be doing 10.4. Then you have your chapter 10 review. And that should, the practice one that I did should be available on the document sharing. Then you're going to take that chapter 10 test. So again, once you finish 3 sections in the chapter 10 review, email me. I'll send out the password for chapter 10. I believe right now, even your review for your final and your final exam are all unlocked. So you kind of work at your pace. All I'm telling you is that by May 6th, there will not be an extension beyond May 6th. So everything has to be done by May 6th. You can't email me May 7th and just say I didn't have time for whatever reason. Everything remaining in the class must be done because I have to submit your grade early in the morning, May 7th. So again, you got some time. We're on April 22nd now. Finish up your chapter 10, take that chapter 10 test, do your review for your final, and then go ahead and take your final exam. And then, like I said, I'll have those grades posted on May 7th. And just again, understand as well, anything that is left that you didn't complete for whatever reason will turn into a 0. So it's not necessarily reflected on your grade right now. It might just show as a missing grade, but until I actually apply that 0, that'll have an effect. So again, I would make sure you go through and check your all sections. And if there's a section that whatever you didn't get to do, you need to email me, let me know, I'll unlock it for you. Or a section that maybe you want to get a better grade in. Remember, what I said is all these sections really should be hundreds because you can do those problems as many times as you want. Your review should also be hundreds. The only thing like that I say that maybe won't be in 100 is these tests, okay? Because those you take once. But again, all your classworks, these homework assignments, really should all be 100. So if they're not, if you have a 95, it's probably not going to make that much of a difference on your grade. But if you have something where you have a 20 or a 0, you definitely want to get in there, get that done. Just, again, like I said, let me know. And I'll unlock it for you and give you the opportunity to go ahead and change that 0. You just don't want zeros. Zeros really have a negative effect on your grades. I tell all my students that, even with the high school, even at Vanguard, you'll take a 50 any day over a 0%. So, all right, moving on to 10.4. Again, we're dealing with these radical expressions. So first thing I do when I know I'm dealing with those, I kind of fill out, that's kind of like my key. So I know my perfect squares because we're going to be using these again when we're simplifying a lot of these radicals. So you're going to start out adding and subtracting. The first example, 4 square root of 48 minus 2 square root of 32 plus square root of 75. Okay, so we are in this problem, you are subtracting here and then adding. So you're adding and subtracting these radical expressions. First thing you have to recognize is every one of these radicals is not in simplified form. So if you go back to 10.3, you usually just had 1 and they told you, okay, simplify that. So now what we're doing is we have actually 3. So we can't add or subtract any of these until these radicals are simplified, because in their current state, these are what we call unlike radicals. You can only add and subtract these together if their radicals are the same. So when we look at it initially, all these radicals are different. But again, they're not complete because they're not simplified. So first thing we have to do is go ahead and simplify these radicals. Now again, I'm going to not spend as much time as I did with 10.3 with simplifying these, but again, you're looking for a perfect square that will go into 48, and normally the highest number. So just a quick little review, if you think of where 48 is right below 49. So I need to find, I don't look at these numbers above, okay, I'm looking at the numbers below 48. And ideally, I want the highest one. So really, yes, 4 will go into 48, but that's 4 is not the highest radical that will go into it. 16 is. So I'm going to rewrite that square root of 48 as the square root of 16 times the square root of 3. I always want to put the perfect square first. 16 times 3 would give me back to 48. So I put my perfect square first because that 16 turns into the 4. So remember, I had the 4 out in front, which again is multiplying. I rewrote the 48 as 16 times 3. Square root of 16 turns into 4. So now I have 4 times 4 out here and the square root of 3. And this is what that'll look like. So the 4 square root of 48, after I simplified it, turns into 16 square root of 3. And that's what you're going to have to do on each one of these, is finding that perfect square. Again, 32, you may be tempted to say, oh, 4 goes to the 32. Okay, but that's not the highest number. It's 16 times 2 will give me 32. So this is going to look like this, 2 times 16 times 2. Square root of 16 turns into the 4. So I have negative 2 times 4 gives me a negative 8 square root of 2. Okay, so negative 2 square root of 32, after it's simplified, turns into negative 8 square root of 2. And the last one is 75. Quick little hint with these, anything that's going to end in a 5, the first one that I'm always going to check is 25. Okay, that's just going to be 25 times 3. 25 times 3 gets me to 75. Square root of 25 equals 5. So this turns into 5 square root of 3. I'm just going to move this down. So now we took all these 3 terms, we simplified them, and this is what we have. Okay, so when you're adding and subtracting radicals, it's similar to variables. I can only add like radicals. And what you'll see is I have a radical 3 and a radical 3. Square root of 3, square root of 3. I can combine these, okay? And then it's just like with variables. You're just adding the coefficients, adding the numbers in front of the radicals. So in other words, I'm doing 16 plus 5, which would give me 21. You keep the square, you don't add the radicals together, you just keep the square root of 3. And then since this is an unlike radical, you're going to have that kind of behind there. All right, so that would be your answer. We cannot add these together. These are unlike radicals. Okay, so that my answer, it stops right there. So you had to originally take these numbers, these terms, simplify them, get them to here, and then our last step is combine. If any of the radicals are the same, we can combine them. If they're all different, then you just keep them all different. But we're adding the like radicals, and then it looks like that. And that would be your answer for that problem. I just want to go, there is a slide on the PowerPoint that kind of emphasizes this like radical thing that we're talking about. And so again, what you see is here, these radicals are the same. It's another square root of 3. Remember, the coefficient there, even though you don't see it, is 1. That's how they get 8. So 1 plus 7 gives me 8. On this one, again, they are like. They're square root of 2. So you go 10 minus 4 is 6 square root of 2. And then what you'll notice with C, 1 is 5, 1 is 3. So you can't simplify. They just stay. That is the answer, square root of 5 plus square root of 3. And I wouldn't worry so much about D. um, because we're not really, we're dealing with everything with a power of 2, which that's more into algebra 2. All right, so just remember, we can combine like radicals. We cannot combine unlike radicals. All right, the next one I want to look at is kind of like a fraction. What's nice about these, though, what you will notice is, remember when we're adding, subtracting fractions, what must we have? We must have like terms in the denominators. We have to have common denominators, right? The same denominator. So we can add these two together. The problem is we have a 5 here and a 20. These are not the same. This one is actually simplified because there's not a perfect square that goes into 5, but there is a perfect square that will go into 20. So I'm just going to, what ends up happening, guys, is you end up simplifying the same radicals multiple times. So if you're pretty good with your work, you maybe you've already simplified square root of 20 somewhere. And if you could find that, you're just going to go, well, I know the simplified version of square root of 20 is 2 square root of 5. Okay, so what you're going to do is you're going to replace the square root of 20 with 2 square root of 5. Okay, so initially they weren't the same, but after I simplified square root of 20, now I notice they are the same. So I'm going to keep the square root of 5. And then all I'm doing is, what's 4 take away 2? That'll give me 2. Keep my common denominator. And there's my answer, 2 square root of 5 over square root of 5. All right, let's look at one more with adding and subtracting before we get into some multiplication problems. All right, 3 square root of 25 minus 11 plus square root of 5. Obviously, this is a constant. It's already simplified. Square root of 5 is in a simplified form. So we have 3 square root of 25. But what you notice about 25 is one of our perfect squares. Square root of 25 equals 5. So what I'm going to have is basically 3 times 5 minus 11 plus square root of 5. Well, what's 3 times 5? That's 15. So we got 15 minus 11 plus square root of 5. 15 minus 11 gives me 4. So I got 4 plus square root of 5. I cannot just, this does not become 4 square root of 5, okay? This just becomes 4 plus square root of 5. Why can't I add these together? Again, I need to have like radicals. If this was square root of 5, then I can combine these into one term. But this really, the radical here is square root of 1. Right, so this remains separate. Do not make this 4 square root of 5. This is 4 plus square root of 5. I can combine my constants, but I can't combine them with a radical. Constants don't combine with the radical. If I'm multiplying 4 times square root of 5, then yes, that becomes 4 square root of 5. But I am adding. Anytime you're adding or subtracting, they must have like, what we call like radicals. All right, so let's go into some multiplication problems. All right. So this kind of takes us back to monomial times a binomial. And what are you supposed to do when you see something like that? Well, you have to distribute. So I have to take that radical 2, multiply it by radical 7, then take the radical 2, multiply it by radical 3. And then I would look to see, is there any way I could simplify anything? So start out, what's 2 times 7? 2 times 7 is 14. You keep it inside this radical. 2 times 3. 2 times 3 is 6. So I have square root of 14 plus square root of 6. That is all I can do there. I cannot simplify this. There is no perfect square that goes into 14. There is no perfect square that goes into 6. I can't combine these because these radicals are different. So you are done with that problem. Let's just go ahead and do another one real quick. You can see some of these aren't too bad. You just got to understand when I can simplify and when I can't. So we're doing 11 times 2 gives me 22. And 11 times 7 gives me 77. You can go ahead and check these perfect squares if there's a perfect square that goes into any of these, but you will notice there is not. So this is actually in its simplified form. I cannot add these two together. So it just remains square root of 22 plus square root of 77. That kind of sets us up to our next problem. We're on example 6. All right, so we're going to have actually a binomial times a binomial. And that's where we kind of do our FOIL. I'm not, like I said, you guys know I don't use FOIL. But what I do is you take your first term and you're going to multiply it into both terms. Then you're going to take your second term and multiply it into both terms there. We're going to start with 2 square root of 3 times square root of 3. Again, think of this as like a 1 here. So you multiply the coefficients in front. What's 2 times 1? That gives me 2. Now, when you are multiplying radicals, okay, different than adding and subtracting, you actually do multiply the 3 times 3. So what is 3 times 3? That would give me 9. And you may initially say, oh, that's a perfect square. I can simplify that. Yeah, we're going to come back to that. Let's just FOIL everything out, and then we'll go look for our like and unlike terms and simplify whatever we have to do. Next thing is 2 square root of 3 times 8 square root of 7. So first thing is 2 times 8. 2 times 8 would give me 16. And then we do the radicals inside. 3 times 7 gives me 21. All right? And again, we're going to check later to see if they simplify. All right, let's go back. Let's work on 7 now. We're doing 7 times square root of 3. Remember, there's a 1 here. So 7 times 1 gives me 7. And since there's no radical on this, it just is 7 square root of 3. So that's what 7 times square root of 3 gives me, is 7 square root of 3. Now we're going to 7 times 8 square root of 7. So in this problem, all we can do is really multiply these coefficients. 7 times 8 gives me a 56. And I keep the square root of 7. There was not a radical on the 7. So now this problem in its current state looks like this. Okay? And then I just noticed I wrote this problem wrong, because this 7 right here was supposed to be inside a radical. So let's see how that's going to change these over here. So this doesn't affect the first part of the problem, but sorry, this is incorrect. So let's do that again. Square root of 7 times 3 gives me a square root of 21. There's no coefficients, or there is coefficients. It's 1 times 1, so really this is a 1 here. And now let's do the next one. There's a 1 times 8, so that gives me 8. And then we're doing 7 times 7 gives me 49. So I'm just going to rewrite these. I'm going to move these other ones down since I kind of messed up a little bit on this problem. All right, so this is what it looks like. Now we're going to work on simplifying a little bit. Hopefully what you notice is that 9 is a perfect square and 49 is a perfect square. Square root of 9 we know equals 3. Okay, what else you may notice is these terms in the middle, they both have square root of 21. So we can add these two together. Remember, this has a 1 in front of it. So 16 plus 1 would give me 17 square root of 21. And then the last one we notice is that square root of 49 is a perfect square, and that equals 7. So let's just clean this up. 2 times 3 is 6. 17 square root of 21, and 8 times 7 is 56. We're looking for our like terms. Our like terms are going to be both of these constants. We can add those. 56 plus 6 will give me a 62. And then again, I cannot combine these because this one has the radicals and these are just constants, so they do not, they are not able to be simplified. And this is probably one of the harder problems that we will see on 10.4. So, and I kind of butchered it. So let's look at one more example of one like that. All right, same type of problem, binomial times a binomial. Take your first term, I'm going to multiply it by both terms in the second. So it's 4 square root of 5 times square root of 5. Constants, that's right. Let's just throw in the constants already in front, the coefficients, sorry. So 4 times 1 gives me 4. And then 5 times 5 gives me 25. That's my first term. Now we're going to go to the next one. 4 square root of 5, and this is a minus, so that's important. Let's put that in there. 4 square root of 5 times negative 3 square root of 3. So first thing we do is 4 times 3 would give me 12, and we know it's negative because it's negative here. And then 5 times 3 gives me 15. All right, so now we're going to move to the 6 square root of 3. 6 times 1 gives me 6. And again, 3 times 5 is square root of 15. And our last one, 6 square root of 3 times 3 square root of 3, 6 times, and it's negative. 6 times negative 3 gives me a negative 18. And we know that 3 times 3 is 9. So hopefully you can read. I'm going to rewrite it just because of my lines are kind of mixing in. All right, so that's where we are. Once we FOIL or once we distribute these two binomials, the problem looks like this. Okay, and hopefully you guys will notice that these two are my like radicals. Okay, that's really it. But what we should notice as well is that this is a perfect square and 9 is a perfect square. So this is going to look like 4 times 5, and 4 times 5 is 20. I can combine these because they are like, and I just go negative 12 plus 6 would give me a negative 6. Square root of 15, keep the square root. We know that square root of 9 is 3. We got to do 18 negative times 3, which will give me a negative 54. So I can combine 20 minus 54. So 20 take away 54 is going to give me a negative 34. And then I just move that negative 6 square root of 15 behind it. And I stop there because this does not have a radical. That's pretty much all I can do. So guys, now we are done with Intro to College Math. That is all the material that is covered on Intro to College Math course. Hopefully you guys brushed up some on your math skills, and now you'll be ready to continue on with your college math classes. I'm hoping that you guys, like I said, improved your skills, and this class has been beneficial for you going forward. I thank you guys for adapting to to what's kind of going on in the world now, where we're meeting there, you know, twice a week, to everything going online. So, like I said, I just hope that you guys, you know, learn some skills like that will help you guys going forward in college. And again, just a little reminder that we need to make sure everything is done by May 6th. So again, I would caution you guys, don't wait till May 5th to do all your sections and all your chapter 10 and all that kind of stuff. Ideally, you're staying on our same schedule where you'll have all this stuff done before Monday. You could maybe take your exam on Monday. This was another no class day because I think I was supposed to be in Pensacola. So it just kind of gives you a little more time before the final. So I think I already have one student that already took they did the whole class. They did their chapter 10 tests. They've done their final exam, so they're all done. And that's why I kind of unlocked it to you know, give you that opportunity that if you have the time, and you know you have the time now, to just go ahead and finish it up. But like I said, I can't give you, I know some of you have been giving you extensions, but I can't do that here. Everything has to be done by May 6th. So please keep that in mind, and you all stay safe. Thank you again for adapting to the class. And hopefully I'll see you guys soon.